Okay. So question number 6 says a pentagonal pyramid of 25 millimeter side base and 50 millimeter axis length rests on HP on one of its corner of the base such that the two base edges containing the corner on which it rests make equal inclination with HP. This we have seen in planes also. Draw the projection of pyramid when the axis is inclined to HP at 40 degrees and appears to be inclined at 45 degrees to VP. You know, this particular word appears, we have seen this before in projection of plane. So let me just revise that again. Okay. So in the given data, how to identify step 1, 2 and 3. First, wherever it is resting, that particular plane and the data related to that will be your step 1, like the pentagonal pyramid of 25 millimeter side of the base and 50 millimeter axis length resting on HP on one of its corner of the base. This complete information will be my step 1. Then wherever it is resting, step 2 will be usually with respect to that, like it is resting on HP, so the axis inclination to HP at 40 degrees will be my step 2. And the last information which is appears to be inclined at, I mean what is appears axis is appearing to be inclined at 45 degrees to VP, that will be my step 3. Okay, so let me remember this pentagonal pyramid 25 millimeters side and 50 axis length. Okay, so I'll write this data in step 1, 2, 3. Okay, so then I can start with the question. Okay, so what is given here? Step 1, it is a pentagonal pyramid. See, by default, whenever I say pentagonal, any pyramid, by default, it is a regular pyramid. Okay. So pentagonal pyramid, 25 mm side of the base. Okay. Side of the base and axis height is 50 millimeters. Okay. Axis height is 50 millimeters and it is resting, sorry, yeah, resting on HP on one of its corners of the base, on one of its corner of base. Okay, so this complete information will be my step 1. Step 2 will be axis inclined at 40 degrees to HP. So it is resting on HP, so inclination with respect to HP will be my step 2. So again, axis appears, so axis appears to be inclined at 45 degrees to vertical plane. So just remember this particular word appears. Okay, so just remember this particular word appears. We'll talk about that. This particular word appears, we'll talk about that in the step 3. So I'll tell you what is the importance of this word there. Okay, so to start with, I should start in the top view because it is resting on HP, because something resting on HP can be seen in the top view. So I'll start with the top view. Now, should I start with a corner or a edge? That's the question. If it was planes, if it is resting on corner, I should have started with corner. But I told you in solids, we have to end with wherever it is resting with. Like it is resting on corner, so I should end with a corner. That means corner should be onto my right side. So for a pentagon, if corner has to be here, the edge should be in the starting. So don't remember where to start with, just remember how to end with. So here it has to end with a corner. So now I'll draw a pentagon ending with a corner. Okay, so pentagon is 5 sides. So I'll draw a pentagon ending with a corner. Now what is the size of the pentagon? The size of the pentagon is 25 millimeters. So remember this way, resting on HP, so I'm drawing it in the top view. Resting on the HP, so I'm drawing it in the top view. And resting on the corner, so I'm ending with the corner because it is solids. Okay, so it is solid, so I'm ending with that corner. Now, next thing that I have to do here is I have to draw the slant edges. Because it is a pyramid, I can see the slant edges also. So because it is a pyramid, I can see slant edges also. But where to start with the slant edges? Slant edges meet at the center. And for a pentagon, how to find the center? Simply draw the perpendicular bisectors. So perpendicular bisectors, how can that be drawn? The simplest way of drawing perpendicular bisectors is, okay, simplest way of drawing perpendicular bisectors is join one corner to opposite side midpoint. What did I do? Join one corner to opposite side midpoint. Do the same for another corner also. If you do it for two corners, you will get what is required. Okay, wherever these two are meeting, that is the center. See, this is just to find the center. Understand? This is just to find the center. Now we have to draw slant edges. Slant edges will be from each and every corner to the center. Okay, so slant, so now I can delete these two because now I can find where is my center. So slant edges has to be from each and every corner to the center. Okay, so to find the center, I draw the perpendicular bisectors. But once I get the perpendicular bisectors and center, so I'll join everything with the center. Okay, so this is how the top view can be drawn. Now coming to the naming. So again, I told you. So I can give the names in one single sequence. Either you can follow it clockwise or anti-clockwise, but just do only one thing, not both. Okay. So A, B, C, D, E, and the center, top of the center will be O, and below that we will have O1. That is the base of the axis. O is the top of the axis and O1 is the base of the axis. Okay, so yeah. So that's how we can find. The next thing is, let me make these things dark. Okay, that means let me give some line weight to it. Okay, so let me give some line weight to it. Sorry. So this you are supposed to do it for every figure. Okay, so this will be my initial starting point. Okay, once I get this starting point, next thing, as it is a pentagon, I'll see a triangle in the front view. Okay, so now how to draw the triangle? First thing that you can do is, from the center draw a line. From the center draw a line and name it as O1. From the center draw a line and name it as O1. As it is front view, it will be O1 prime. From the O1 prime, take the axis height. What is the axis height? Axis height is 50 millimeters. So take 50 millimeters and then you get the point O. Okay, so this is how we are supposed to find axis. Remember, when drawing the front view, the first thing that you are supposed to do is to find the axis. And where are we going to draw the axis? From the center. Okay, so once axis is dash and dot line like this. Okay, axis is not continuous line, axis is dash and dot line like this. Okay, so once you get this, then follow this simple procedure. From every point, you can see, if I draw it from here, D and B are going to be there on one single point. Okay, done. Okay, so now I got 3 points. The next step is, from each and every point we are supposed to join the apex. So from apex I'll join this, from apex I'll join this particular thing. Okay, and from apex I'll join here. The next thing will be naming. To give the name, if you have any doubts in naming, the first thing that you can do is, this is front view. So imagine as if you are seeing from the bottom. So when you see from the bottom, the first point that you see is E here, correct? So the first point that we see is E, and behind E we have A. So behind E we have A, so write A prime in the bracket. Again, for this particular line, first we see D, so that point should be D, and behind that we have B. Okay, so as it is front view, I'm just marking a prime, and here we have only one point, so simply name that particular point here, that will be C prime. Okay, so I have given the names. Next thing, I'll just make these things dark, whichever is required. Okay, so I need to join these two. Okay, done. So this will be my step one. So to complete the step one completely, so let me give the dimensions which are supposed to be there. One dimension is 25. Remember, when you write all dimensions are in mm, please don't write mm again. Okay, so this is a common mistake that you people made in your exam most of the times. So okay, sorry, there's a small, so 50 till here. Oh, what's wrong in this? Maybe it is taking some thickness or what. So it was supposed to be 50 there. Okay, so this was supposed to be 50 millimeters. This was supposed to be 50 millimeters, not 50.2. It was supposed to be 50 millimeters. Okay, yeah. So the next thing, once we are done with the step one, the next thing is axis is inclined at 40 degrees to HP. Yesterday I told you, when axis is inclined at 40 degrees to HP, the base will be inclined at 90 minus 40. So if the axis is like this, if the axis is inclined at 40 degrees like this, okay, base will be inclined at base will be inclined at 90 minus 40 degrees. Now what is 90 minus 40? It should be 50 degrees. Okay, okay, let me take some random value. So okay, so if the axis is inclined at 40 degrees, the base will be inclined at 90 minus 40 degrees. So this particular logic we are going to use when we are going to draw the step 2. Okay, so please remember this: when axis is inclined at theta, base will be inclined at 90 minus theta. So instead of drawing axis inclination, I'll draw 90 minus theta here. Okay, so I'll be drawing 90 minus theta. 90 minus theta, that is 90 minus 40 is 50 degrees. So I'll make sure that I have drawn 50 degrees inclination here. Okay, so instead of drawing 40 like this, I'm drawing 50 in the other direction. This is 90 minus of whatever the angle given. So once that is there, to the left, sorry, to the rightmost point, whatever we have, place it there first. Okay, so this will be the rightmost point. After this, take your compass, measure the distance between C and E. Measure the distance between C and E. You don't have to write this, just to show you I'm giving this. Using your compass, you can just measure this value, and using the same length C as the center, draw an arc to get the point there. Okay, so then you get the point here, that is E prime A prime. So once you got that, you don't need that value again. So what did I do? Using my compass, having C as the center, measured E prime and cut the arc here. The next thing that I can do is, same way, measure what is C prime to D prime length. C prime to D prime, and take your compass, again C as the center, C as the center, and that particular length, whatever you have measured just now, that is, cut an arc here. Then the point that you get is D prime, B prime. So I have got 3 points. The next thing that I need is O1 prime. Okay, so O1 prime, let me just move it a bit aside here so that we can see it. Yeah, O1 prime. So I'll do the same here. Okay, once I get, I don't need this value. So measure C prime to O1 prime. Okay, measure C prime to O1 prime. Take the compass, C as the center, with the distance that you have measured just now, draw an arc. Okay, and you get O1 prime there. You get O1 prime. So on the base, I have marked all the points. Next, I have to mark O prime. Okay, so for that, what I can do is measure. Okay, so measure C prime to O1 prime, sorry, O prime. Okay, it is 54.36. So again, take your compass, C as the center, draw an arc with the length 54.36. So I have simply drawn an arc. So once I have drawn it, it's not required. Now I'll measure the same from E prime also. It is 52.86. So I'll take the compass again from this point, from E prime, I'll draw an arc with the length that I have measured just now, that is 52.86. Okay, wherever these two meet, that will be my point O prime. Okay, see, in AutoCAD I could have just copied and pasted it here, but I'm showing you how you can draw it in your book. Okay, so once you have done this, the next step will be to join these respective points. So just join O to each and every point there. Again, let me remind you, this figure and this has to be exactly same. Okay, you make sure that these two are exactly same. So whichever is axis, it has to be axis here. Whichever is continuous line, that has to be continuous line here. Okay, so let me just make, oh sorry, that should not be there. So this particular line, let me make it exact till here. Okay, done. And I have O1 prime as an axis, so I'll make that particular thing axis. So once you get all these things, you can remove the extra arcs that you have drawn, which are not required now. Okay, so whatever the arcs that you have drawn in the construction process, you can happily erase them. You know, they are not required anymore. So let me just move the C prime a bit aside. Okay, so this is how I'm going to do second step. What is the dimension that we are supposed to give here? You are not supposed to give 50 degrees, but we are supposed to mention this particular dimension that I have shown initially for construction purpose only. Okay, so this has to be 40 degrees. What's happening with this? Okay, so this has to be 40 degrees. This is the dimension that we are going to show here. Okay, so once we are done with this, the next step will be from O, draw lines here. That will be your new O. Okay, do the same for O1 also. Okay, that will be O1. Do the same for C. C is also on the same line, so that is your new C. Now E will be from here, so A will be, okay, so A will be from here to here. Okay, then do the same for D. So D is here. B will be from there to here. Now, how to complete this figure? Please follow this notation. So before drawing anything, first give the naming. Where is A? This is point A. This is the point B. Because you make any mistake in giving the names and everything is gone. So this is D. This is E. So this is my O. So let me write it as O. And this point at the center is O1. So edit it to O1. Okay, this particular point is O1. Once you have identified all the points, how to finish this figure? So first simple thing that you can do is join the base, that is A to B. Okay, A to B, B to C, C to D, D to E, and E back to A. So this is completion of base. So now you have drawn the base. Once you have drawn the base, you can delete these construction lines if you don't want it. Okay. So once you have drawn the base, you don't need that anymore. Okay. So you have drawn the base. The next thing is from the apex, join each and every corner of the base. So from O to A, from O to B, from O to C, from O to D, from O to E, done. So first I have drawn the base, then join apex to each and every corner. The last thing that I have to do is join the axis. Join the axis. Done. Now the question comes, what should be hidden lines and what should be the axis? First thing that straight away we can do is mark the axis. So this particular line is axis. We already know O1 is axis, so mark it as axis. Done. The next thing that you can do is all the outer boundary of this figure should be dark. I mean continuous and dark. So this step is simple. Now whatever the lines which are remaining, that is this lines whatever are remaining, now we have to think about those lines. First let me think of the line OA. So when I'm drawing the top view, remember, I mean imagine as if you are seeing from the top. So when you are seeing something from the top, can I see OA line? Yes, I can see when I'm seeing it from the top. So I'll make it dark. Okay, I'm making it dark. Can I see the line OE from the top? Yes, I can see because that's the topmost line that can be visible. So I'll draw that. Next question comes here. What about the line BC? Can I see this? See, the line BC is at the bottom. Just imagine if this is a solid and when you are seeing from the top, can we see this particular line? We can't see that. So that particular line should be hidden. Okay, hidden as well as dark. Okay, so that particular line is hidden. The same case with CD. CD is also the particular same line at the base. When I'm seeing from the top, can I see that? We can't obviously see that. So even that particular line should be hidden. Next, coming to this OC, again OC is also at the base. Can we see that? We can't see that. So what are the hidden lines in this? The line joining C are hidden. The line BC, line CD, as well as line OC. Okay, so this is how we have done that. So we have completed the basic steps here. This is step 2. Coming to the final step, step 3. Okay, step 3. I told you I'll be talking about the word appears. What is the use of it? If you remember from projection of planes, whenever you see the word appears, that means they have given apparent inclination. And if you don't remember that, always the true length will be on true inclination, apparent length will be on the apparent inclination. Now here we have to find whether this apparent inclination, are we going to use it for true length or apparent length? So what is inclined here? Axis is inclined. So what is the true length of axis? True length of axis is 50 millimeters. Now what is the length of axis in the second step? The length of axis in second step is 38.7. That means the length of axis has reduced. So whatever the length of axis that you are seeing here is apparent length. That means you are going to use this apparent inclination straight away, because they have straight away given the apparent inclination, so you don't have to draw any extra geometry for apparent inclination. You can straight away use that particular angle and place this entire figure on that like this. So I can straight away draw a line which is at 45 degrees. Okay, so I'm just drawing a line which is at 45 degrees. So let me show that angle here. So I'm drawing a line which is at 45 degrees here. Okay, on this particular line I can straight away place this axis. Now how to place the axis? Simple. So take any random point on this line first and give the name as O. Okay, give the name as O and measure what is O01. What is the axis length? Measure what is O01. Measure what is O01. It is 38.7. So take your compass. This as the center you can draw 38.7. Okay, done. So that particular point will be your O1. And once you get 2 points, we know how to draw the entire figure on that. Correct. So what we can do is take this entire figure. I'm not going to show you how to draw it again, because to measure the distance of each and every point with respect to O and O1 and cut the arc, you will get all 5 points. So here what I'm going to do is straight away use this entire figure and place it there. Okay, so I'm going to place entire thing. So I'll use this command called align. Okay, enter. So I'll place this O on this point O. I'll place this O1 on this point O1. Enter. That's it. So what did I just do? First, we mark O as well as O1. We mark O as well as O1. Okay, first we mark O as well as O1. Then with respect to O and O1, find all the other points. So whichever is continuous tick here, it will be continuous tick. Whichever is hidden here, it will be hidden here also. Okay, once you are done with this, the final step is easy to find the final points. Find from O to O prime, that will be your new O prime. Okay, so when you are drawing it in the book, please draw it like this. Okay, so not like this line is not proper. So when you are drawing in the book, draw lines joining from both the points so that you don't have any confusions. So point C is there on this line, so point C will be there on that line. B will be somewhere here, so join B. Okay, D is also on the same line, so join D also. Okay, then find out A and E. It is here. Then from E also. Okay, so do it from E. So we'll get the point E. Then the final point that is left out is the other end of axis O1. So find out where is O1. So it's very close actually. So O1 is very close to E. So sometimes there might be a smallest mistake that will clear everything. Okay. So it's here. Done. Okay. So now we have got the points. Again, how to start with? Start from A, then go to B, then to C, D, E, and back to A. Okay, so that will be your basic loop. So before that, if you want, we can give the names first and then start drawing it. That will be easy. So this point is A. Okay, so this will just eliminate any mistakes if we do. Okay, that point is E. Then comes, that is B. Okay, and this particular point is D. So when naming the points, just be careful. Okay, because this is where most of the mistakes happen, and you make one mistake and everything is gone. Okay, this particular point is O1 prime and this particular point is O prime. So now I have joined the base A to B, B to C, and all the base A to back to A again. Next thing that I am supposed to do is from the apex join each and every point. From the apex join each and every point like this. So O to D. Oh, sorry, this is not complete. So join O to D, then O to E. Okay, this completes joining point from apex. The last thing, join the axis. Axis from O to O prime. So one thing that I know is axis remains axis, whatever it is. So I'll make it the axis. It is dash and dot lines. Okay. The next thing I'll do is I'll make the outer boundary thick. So this is the outer boundary for that figure. I'll make it continuous dark. Okay. Now comes the question. What about the other lines? Now, if you see from the bottom, if you see from the bottom, so what are the lines which we can see and which we cannot see? That's what we have to identify. So when I see from the bottom, can I see the line ED? Yes, I can see it. So I'll make it dark. Can I see the line AE? Yes, I can see that also. So I'll make it dark. Next, when I'm seeing from the bottom, can I see this line EVO? Yes, I can see it. So I'll make it dark. What about the DO? That I have already done that. Next, what about this CO? I'm not sure whether I can see it or not. So make it hidden there. Okay. So make the line C prime O prime hidden. And what about the BO that is completely on the other extreme? I can't see that also. So make it hidden. Okay. So this is how we can complete the figure. So what are the dimensions that we are supposed to give? First, the size of the pentagon, then the axis height, inclination with respect to HP, and inclination with respect to vertical plane. So if you are done with this, your problem is done. Okay. So it's very simple. Here, we did not do any apparent inclination method because they have already given the apparent inclination. If they did not give it, then we have to find the apparent inclination and then we have to do it. So if you know this question number 6, it will be helpful to solve question number 8 also. Okay.